Here we are going to discuss primes and the greatest common divisors of the numbers. I start with complete list of all positive integers up to the desired limit, and we call the limit by n. 1 does not count, we will not count 1. Remove all multiples of the lowest prime number 2. Secondly, remove all multiples of the next lowest prime number 3. Then remove all the multiples of the next lowest prime number 5. Remove all multiples of the largest prime number less than equal to square root of n. So here for these numbers 2, 3, 5 dot dot up to the square root of n, first of all we have to construct a table, and we will try to put the numbers between 1 to 100 like here you can see I am highlighting the number. Start with complete list of all positive integers up to the desired limit. Here n is equal to 100. These are the numbers 1, 2, 3, 4, 5 up to 100, and starting with prime, not including 1. Here we are not including 1, so we have to remove 1, and thereafter start the counting by the multiple of the prime numbers. Here remove all multiples of the lowest prime number 2, then the 2 having multiples 4, 6, 8, 10, 12, 14 up to dot dot dot. Here 100 will be the last point, and simply all the even numbers up to 100 starting from 2. So here 2 is the prime number, and we have to remove the multiples of 2 like this. Thereafter we have to remove the multiples of 3. So here 3, 6, 9, 12, 15, 18, 21, 24, 30, then 33, 36, and here 39, 42, then 45, then 48, here 54, and so on. So these are the multiples of 3, and 3 is the lowest prime number after 2, and then after 5 is the lowest prime number after 3. So here we have to take the multiples of 5. Here 5, 10, 20, 15, 25, and so on. So here like this. And after 5, 7 is the lowest prime number. So here 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, and so on. So here we have to remove all the multiples of 7. What we observed, those are all of the primes less than equal to a square root of n. So we are done. The remaining elements in our list are the